Hello and welcome to Unit 4 Opener number 10, where we'll be solving some more quadratic and absolute value equations. If you're just joining this, you may want to go back and look at Unit 4 Openers number 8 and 9. They start with sort of the basics of quadratics and absolute value. These are a little more advanced. Now, one mistake people make when they look at a quadratic equation such as this is they sort of jump the gun on square rooting. Now, it's true that at some point we are going to square root both sides of this equation. But if we square rooted both sides right now, you'll notice we have to square root the entire side, which means we'll be getting that 7 stuck underneath the square root. And that's just going to lead to ugly things that we don't really want to worry about. So instead, what we can do is let's make sure we get the squared part by itself. Okay, we're going to be isolating the squared part. So the way we can do that is by getting rid of this plus 7. So we can subtract 7 on both sides and get 4 minus x quantity squared equals, let's see, 23 minus 7 is 16. Okay, now that we've isolated the squared term, now it makes sense to square root both sides. Alright, so if we square root both sides, we'll get 4 minus x is equal to 16, or 4 minus x is equal to negative 16. Now, again, if you don't know where the 16 and the negative 16 are coming from, you probably want to go back and take a look at openers number 8 and opener number 9, because that explains that a little more in depth. In any case, now I'm just going to do a little bit of algebra to get this x by itself, so I will subtract 4 on both sides, and I'll have negative x equals 12. Notice that was minus x there, so 0 minus x gives you a negative x. And so if negative x equals 12, in other words, the opposite of x equals 12, that means x itself must be negative 12. And for the other equation, I'll subtract 4 on both sides and get that negative x equals negative 20. And again, that means that x must be equal to the opposite of negative 20, which would be 20. Alright, and same idea here in this second equation. This is an absolute value equation. What we need to do before we're allowed to break it up into our two separate equations, what we need to do is isolate the absolute value. We need to get the absolute value part by itself. So therefore, we have to get rid of this 3 in front. Now, absolute value acts a lot like parentheses. So if I had written 3 parentheses x minus 8, I think most of you would recognize that that means 3 times the quantity x minus 8. Well, this is the same thing. This means 3 times the absolute value of the quantity x minus 8. So in order to undo multiplication by 3, I'm going to divide by 3. So I divide both sides by 3, and I have x minus 8 equals, the absolute value of x minus 8 equals 5/3. Alright, well, now that I've isolated the absolute value, I'm ready to write two separate equations in order to get rid of that absolute value. So I'll have x minus 8 equals 5/3, or x minus 8 equals negative 5/3. And again, if you're not quite seeing why I'm doing this with a positive and a negative 5/3, take a look at openers number 8 and 9 from Unit 4, and that should help clear it up. So in any case, I'm now just going to try to get this x by itself, and since this 8 is being subtracted, I will have to add 8 to both sides. So I'll have x equals 5/3 plus 8 on this side, on this equation, and I'll add 8 to both sides over here and get x equals negative 5/3 plus 8. And I suppose in order to add this 5/3 and this 8, I'll probably want to get a common denominator, which I could just make be 3. So I'll have to multiply 8 over 1 by 3 in both the numerator and the denominator, and I'll be doing the exact same thing over in this other equation. So here I've got 5/3 plus 4/3, and over here I've got negative 5/3 plus 24/3. So at the end, I'm ending up with x can equal 29/3, or x can equal 19/3. So I think the big idea here is simply when you're solving a somewhat complex quadratic or absolute value equation, if possible, what you want to do is isolate the part that's being squared, or isolate the part that has the absolute value around it, and then you're able to break it up into two separate pieces and solve.